geographic, racial, gender, and socioeconomic equity and opportunity for all to innovate to drive economic and community growth.
Finally, the partnership doesn't simply provide financial assistance. It uses a hybrid model that combines grant making with hands-on program operation and infrastructure for researchers, students, nonprofits, community groups, and small businesses across the state.
Together, these four hallmarks form a force multiplier. Here's some highlights from the past year that showcase the partnership's impact and results.
The Working Farms Fund, the first of its kind in the country, helps preserve farmland in perpetuity from encroaching urban and suburban sprawl. The fund has purchased 7 farms and secured 675 acres of farmland for 31 new farmers. 85% of the farms are historically underserved or women-owned farm businesses. The City of Savannah leveraged data analytics and machine learning from the Georgia SMART program to deal with vacant and blighted properties in the community. The multidisciplinary research team analyzed more than 2 million merged real estate data records, including over 104,000 properties, and developed a machine learning algorithm that reaches 87% to 95% accuracy in predicting vacant and deteriorated land or structures. On average, each blighted property identified and ameliorated saves the City of Savannah more than $1,300 a year. The City of Valdosta revolutionized its traffic system and helped first responders arrive faster when seconds and minutes mattered the most. The project connected all 128 traffic signals throughout the city and trained 72 firefighters operating 10 fire trucks on signal preemption. This resulted in time savings of more than 10 critical seconds per intersection and won multiple national and international awards. This year, our impact has included more than 30 active projects, including 10 economic development districts, 14 community research collaborations, 16 colleges and universities, and more than 30 multidisciplinary researchers. Such intentional inclusion has resulted in 24 new businesses created and supported, 71 access to capital opportunities created for entrepreneurs, more than 170 technologies, and more than 25,000 student hours devoted to civic tech projects.
The progress the partnership has made this year shows just how much we can accomplish when we work together.
That's pretty nice.
Thank you. So yes, that video does a much better job than I could do at talking about what the partnership has accomplished over the last 2 years. The Georgia Smart Communities Challenge is just one part of what we do, and so that's what we're here to celebrate today, is what the cohort in 2021 was able to accomplish. So, with that being said, I'd like to welcome Dr. Ledbetter to talk a little bit about what Spalding County has been able to accomplish over the last couple of years, and please excuse any technical delays during this process. Okay.
I'm going to go ahead and run this. I actually want you to see it, and then I want to have a conversation about it as we finish. So just pay attention to what's going on the screen. I'm going to pull this over a minute. So what you're seeing on the screen right now is 35 miles of ring around Spalding County that affords our community to broadcast high-speed internet around our community. That's an interesting way to set up what we've got going on, because we have portions of our community that are not served at all with high-speed internet. The first place that you saw Orchard Hill that the drone flew to, they are an island a complete island. None of our high speed internet providers will come into that city to provide any semblance of high speed internet. That community did just like two other communities that I've been associated with over the past few years. They went and figured it out for themselves, and they offered their citizens high-speed internet. How did we get there? Well, it was a long trip. So some of you have heard, some of you have not. The way we got there, many years ago, I was associated with the oil and gas industry, and from Houston, Texas to a remote location way out in West Texas called Kennedy, there was fiber. And the engineers were able to talk back and forth between Kennedy and Houston in real time. But from Kennedy, 250 miles downrange, which is an interesting, it's an interesting community. It's called the Eagle Ford, and there is absolutely nothing in the Eagle Ford. It's as flat as that table. There are no trees, shrubs, or anything, and you can see for miles. Well, that's where they are digging for oil. So they are producing, on average, about 200 wells a year onshore, fracking, which is an interesting way to bring oil up out of the ground. It's just sand that separates the rock. That's what fracking is. It's chemical and sand. But as a part of that particular field, they have some extreme dangers that go on. One of them is the gas that could form in pockets, and I'm not talking about gas like you put in your car, I'm talking physical gas. And that gas pocket can actually explode and kill everyone on that site. So how do you monitor that on a 24-hour a day, 7-day a week schedule? You can't send engineers there and live because the engineers just won't go. Simply because they like the lives that they have, whether it's in Kennedy or whether it's in Houston, they don't want to be downrange all the time. So we had an option. And the option was, let's figure out how to push high-speed internet to that location without running fiber. So we did it wirelessly. And those engineers physically sitting in Houston, Texas, could watch the screen on a second-by-second basis. And they were watching trend lines, and as they were watching the trend line, they could tell whether or not the drill bit was getting close to a gas bubble. If the gas bubble started to rise and it violated a normal range, they would push a button in Houston, Texas that would go by fiber to Kennedy, that would go wirelessly to the well, and it would close in, literally close in a BOP, a blowout preventer. It would shut the well in, and it would not allow that well to explode. They would lose the well, but it was a whole lot better to lose a well than it was to lose people. All right. So fast forward by about 2 years, and here I am in a small location in Woodbury, Georgia. My daughter is in, you'll have to forgive me, she was in Auburn, Alabama at the university. She did not go to Georgia. But she is in Auburn, Alabama, and I am visiting one weekend, and I asked her specifically because I was working, and I had to ask her forgiveness as well. I was working while I was spending time with her, and we were standing on the campus, and she said, well, Daddy, just log into the Wi-Fi. Here, let me get your phone. And she took my phone, and she logged in for me, and I was able to use my Wi-Fi standing in the quad. And I'm thinking, all right, well, if I can run wireless internet for 250 miles downrange from Kennedy, and I've got wireless internet sitting in the quad that is as strong here in the quad as it would be at the AP, the access point, were physically inside of my room. Why can't I do that in a community? So I started asking all the wrong questions, right? The wrong question was, why can't we do it here? Why can't we put this in play? So we did a small investment, and the small investment for us was $50,000. And I thought that was dirt cheap to heighten the ability for a small community to put high-speed internet in for people to actually work from home, visit their doctor on telemed, or, I don't know, go to school, because we had not had high-speed internet in our community. The best we had was copper wire running on ISDN. You can't even watch, you can't watch YouTube on that. So we made the investment, and we put it into play, and it worked. And it worked so well that a neighboring community came to see us, and they said, how did you make this happen? So we started putting it into play, we started showing that it worked, we started getting some requests across the state on how we were able to do this. And then, you know, all right, I'll ask the question. How many of you in here are engineers? All right, awesome. What are the 4 worst words you can hear an engineer say? Oh! No.
It can't be done. It can't be done.
It can't be done?
It can be done.
It can be done. That's actually really, really close. So the 4 worst words you can ever hear an engineer say, because I have worked with engineers for the last 20 years, is wouldn't it be neat? So the wouldn't it be neat concept actually grabbed hold of me, and I kept asking the wouldn't it be neat question. Well, wouldn't it be neat if we could put high-speed internet in Spalding County? And the wouldn't it be neat for us was we needed to run the ring around the county because we had fire stations within our community that did not have access to high-speed internet. So the first option we put into play was from this location out west, and Blaylock Fire Station is now on high-speed internet using the system that you guys just saw. And the wouldn't it be neat question started to grow. And wouldn't it be neat if we had high-speed internet? Wouldn't it be neat if we had fiber that we could run? Wouldn't it be neat if we converted that fiber in a way that our agricultural homes that are a quarter or a half mile away from the main road were able to gain access to high-speed internet? So instead of running wireless all the way to the house from an antenna, we run it to an access point that's at the end of their driveway because we can run fiber to that access point and then wirelessly shoot it to the house that's a quarter or a half mile away. Wouldn't it be neat if, and we just started asking a million questions about how to solve one problem. And the problem that we were solving was this: how do we afford our community to have high-speed internet, regardless of what means we get that internet to them? Now, granted, you've got large companies like AT&T or Verizon or any of the others, or Comcast or Central Georgia EMC, that are aggravated with our question because it's taking away from their bottom line because they have not caught up with it yet. But I'll ask you the same question that I asked one of my counterparts at Central Georgia EMC. What if you just flipped your model? What if you ran the model so that your fiber ran along the road and you wirelessly transmitted to the house? You would make money off of that, and it would actually build more into your model than you currently have. And he walked away frustrated, not because of my question, but because he had not thought about converting his model that way. What happens when you paradigm shift? When you paradigm shift, you take everything back to zero. And if everything goes back to zero, you have a brand new way of thinking about the world. That's all we are doing here. We're rethinking our world. And the question that we're answering is, wouldn't it be neat if we all had access to high-speed internet? That's the only question we're trying to solve. So that's what we've done here at Spalding County. That's what we continue to do at Spalding County, is ask that one question. Wouldn't it be neat? And then we start filling in blanks that people just haven't considered yet. Thank you for your time. I'll entertain any questions.
Thank you so much, Dr. Ledbetter. So now we're going to transition into our researcher final presentations. We have Dr. Ellen Zagura and Dr. Ada Gavrilowska here today to talk with us about the work they've done this year. Any preference on who goes first?
Me.
I think because that I go first,
Yep.
you're fine, but I did want to ask Steve one thing. So what's the next, wouldn't it be neat set of questions that are coming up?
That's a great question.
In your mind for what you're seeing where you are today?
I actually love your question, but I'm going to turn it on you just for a second. I am so interested in hearing what your students have provided. We know this because we are piled higher and deeper. In every research opportunity, the last chapter is here's what's next on the equation piece for discovery. And I am so interested in hearing what you guys have come up with through your research so that we collectively can sit down and understand what the next opportunity is. I do believe that there are many opportunities available for us. My son-in-law is a part of the NASA program, and he has been associated and affiliated with putting Starlinks in for the last 2 years. And one of the things that he and I have been bantering back and forth over the last 6 months is not to cast aspersion on what's going on, but they have a 30% rate of failure. So in fact, I challenged him the other day, and I challenged him this way. I said, run your Bible. What does your Bible say for the failure rate? And he was like, I'm not doing that. That's math that I don't want to get into. I said, but if it's 30%, what does that mean for the customer for Starlink? And if it's low orbit, is there an option to push it out another mile or two so that you get out of low orbit and you lose that failure rate? He said, I don't know. He said, that's a different, he was trying to push it away. But recognizing that there are some challenges with Starlink, not just with the latency that they're starting to experience because they're loading those up, and it's really causing some challenges. I think that is one option for us, but it is an option. Fiber is an option. Wireless is an option. And I am really, really thinking through what that leap is going to be for that next opportunity that we have coming toward us. And that next leap really does depend on the research that you guys are doing right now, because you're going to lead us into that next area of discovery.
So I have a follow-up. So how do you go about designing the network in the first place? Do you have like robust planning in place to make sure if one thing goes down that there's another route? Do you have like optimizations in place, or is it kind of like situational, ad hoc? What was the process?
You're asking me to be an engineer, and I'm not.
Okay.
So I will share with you what I am. I am a business person.
Okay.
I have a PhD in organizational leadership. I don't have a degree in engineering. But that being said, I don't have that.
Okay.
The way that I've designed in my head what this system looks like is, yes, there is redundancy because it is a ring, so there's two paths to a position.
So you can lose one.
You can lose one and still retain the other.
Yeah.
But I can tell you that I did not do that on my first one. So this is a learning experience for me. And there is opportunity for us to collaborate a lot more. And we've got to sit down in the room and be that entrepreneur and say, all right, here is my dream. This is what I believe. And as a part of that dream and belief, I know that we can deliver high-speed internet to our community. Now let's figure out how we do it. Let's trial and error this until we get it right. And are you going to fail? Absolutely. Every engineer knows that you run things to failure. In fact, I was watching last night, and I'm a geek at heart. I was watching last night, Rainbird actually takes their spray heads and they run them to absolute failure, and then they pull them apart and fix whatever failed, and then they put it back in the machine and run it to failure again. That's exactly what we're doing here. And kudos to Mike, because God bless his heart, he has had to put up with me for the last 16 months, because I walked in the door saying, hey, here is Partnership for Inclusive Innovation. Hook, known as our IT guy, and he has done a fabulous job. Now, we partnered up with some really cool people. Georgia Tech being one of them. The best group we could partner up with was our professors over here, and they have really helped me think through some of the challenges of my dream, because they are pushing me to think to the next level, just like you just did with Hub. Any other questions?
Thank you so much.
Thank you.
Thank you. Thank you, Stephanie, and for putting this together. It's great to actually meet some of the faces we have been seeing over the past year that we haven't had a chance to meet before. So the way we've organized these next two presentations is I will talk first about some of the learnings we have with respect to different options that are available, and then Ellen will go next with some of the more specific measurements and observations that we made over the past year. So I'll tell you where we came from when we got engaged, when Stephanie and Deborah reached out, and why was this particularly intriguing for us from a technical perspective first. There are a number of new trends, satellites being one of them, but there are a number of new trends in that, from a network infrastructure perspective, network service providers perspective, there's a push toward commoditization. There are kind of more infrastructure being opened up. In particular, some of that infrastructure is kind of no longer somewhere in the backhaul of the network, but more at access points. And for someone like me that's coming from the systems perspective as opposed to kind of traditional networking telecommunications, that kind of presented a completely new playground. So there are these like now open test beds that you can log in and it's a Linux box and you can do things there. And why that's happening to ultimately solve connectivity problems, right? You will, so that you can run different services closer to the network, closer to the users, so that you don't have to move all the data and rely, you can get away then with less backhaul internet. And so not only that this infrastructure was opening up, but there were more different software packages that were opening up that would make it possible for you to run real networking services as opposed to some simple prototypes. Like, before, companies like AT&T, they would just build their own proprietary things, and whatever you do from the research perspective, the easiest thing that you would be told would be, well, that doesn't matter because that's not what the AT&T network looks like. But now, with backing from AT&T and Deutsche Telekom, T-Mobile, like a number of different players, there have been several different completely open source stacks that have been backed by the telecommunications community that anybody can access. You can access in Spalding County and build your network with those components, and it can act like the AT&T network, but you will run it yourself. One of the projects that I thought was particularly interesting was a research project that, out of these open source components, built a telecommunications network that spanned the Indonesian islands. Talking about islands, like literally islands, that was completely community driven. So you could use your phone and dial. So this wasn't even just about broadband internet. This was also about like basic cellular service. So these kinds of things, were really interesting to us, and so so we've been working in this space. Like some of the things that we've been looking at were things like, well, how can we now take advantage of all these different compute elements and build maybe new services that do some on-the-fly monitoring. It can be monitoring of agriculture events, can be monitoring of weather events, people, soil, like different types of things. It could be training, right? There is a lot of value these days in machine learning, but all these building these models requires a lot of data, so you can build these distributed training services that, still your data stays in your community. You don't have to share it with somebody else. And then other applications, you can think of, distributed gaming, where, again, your younger population, or at least like the grandchildren when they come and visit the grandparents can stay in schools, right? So there's no reason why you have to rely on content being served from a remote cloud, as opposed to having children drive to the library parking lot. You can just serve your content from the library location and rely on local internet. So we've built these kinds of open source networks and different tools. All of that was lab based, right? So one of the things that that was particularly exciting for us was when we learned about this program was that this could be an opportunity for us to achieve a few things. One is, we felt like we've learned a lot in kind of from the research side, from the research that we've been doing, and so probably there are certain things that we could share with communities and transfer some of the skills from working with these lab-based test beds. And then there were, the other thing was that, there is this next frontier of satellite internet, but it's not like we can get Starlink to give us a satellite so that we can work with, right? Or share the data, or even when it comes to this research of kind of these future edge services, there's a lot of on the research side that we have to speculate in terms of kind of how users are going to interact with those services. So we thought that this could be a great opportunity to, like, on the ground, get some experience, some understanding of, what the demand would be like, what it would fluctuate like, and so inform our work with some real world data. And then we also thought that, in addition to that, this could be an opportunity to actually look at maybe sort of this next phase of deploying some of the things that we've done in the lab or in like simulation, emulation type environments in a real context. I have to say the most eye-opening, so Steve asked me where I'm from Macedonia. It was part of former Yugoslavia, before Yugoslavia broke down into many small countries. It's among the, sort of kind of by economic growth, development, whatever ranking you want to do in Europe and rank the countries, is going to be somewhere at the bottom for them. There is not a square inch in that country that's not covered by high-speed wireless internet. It actually served as a playground for Deutsche Telekom as they were rolling out new services. Kind of, it wasn't, I guess, regulated by some of the EU laws, and so it provided fertile ground for experimental research. But like, to me, it's just been so natural that you go places and you have internet, that and not just internet, just really broadband wireless, and to learn about the state of the service or lack thereof within an hour radius of the largest airport in the world. It was just shocking. I just could not believe that that is even possible. And so I wonder whether there may be like some other types of incentives to get sort of state and federal and corporate partners to incentivize them to come in and address some of the issues, not to turn every single municipality in their own provider. The other thing that I have to say, I've also been beyond impressed at the creativity from the municipalities. I mean, this presentation was really the kinds of things that we learned, and it's just been beyond inspiring to how resourceful all of you have been in trying to solve this. And so, we kind of, it really humbled us, kind of coming into this from a perspective, okay, we'll show them what we can do, and just it's been a great learning experience for us. So what were some of the things that we actually set out to do in this process once we started learning a little bit more about kind of who the partners are? So it's really to take a look at the different communities, the solutions that they're either using or considering, other options that could be available. So in terms of the solutions, when we kind of really started off, there was really the Ubiquity Wi-Fi based solution, which the previous presentation described some of the impact. Over time, we learned of a third-party provider, cellular provider. So those were the available options, and then the things that really we had additional experience with were on the satellite and the private cellular side. And then to try to understand what are some of the metrics, what are some of the kind of different types of requirements and functionality that are needed by the community when trying to think about these services. And so from the metrics, there are really two key stakeholders here. There is the end users, right, the residents in those communities, and then there are the municipalities, which in some cases they're also the service provider, right? And so the traditional metrics in terms of how fast is my internet and how fast, probably don't care about the bits per second as much as I care about my experience when I'm watching YouTube, watching streaming video, having a doctor's visit or whatnot, right? And then the second set of metrics are around how stable that experience is, right? So do I have, can I sort of, is it just always there, or do I have periods of interrupt, periods of degradation? So kind of trying to think about the quality of that experience over time, not just as a peak. And then the second set of metrics from a user perspective are really the cost, right, the bottom line. And one specific number that we heard from several of the communities that we spoke with was $50 a month, kind of things that it need to be $50 a month, under $50 a month. That not necessarily that's always the case, but as a goal that would be in terms of the end user cost, keeping the monthly premium low and keeping the equipment investment low. And then from the municipality perspective, because the first order metrics is about, do my residents have this service? So in terms of coverage, in terms of quality level across the community. And the second set of metrics concerning any of the solutions being considered has been mostly about what does it cost me to operate this? What does it take for me to operate this? And what does it take for me to grow this as I expand coverage, as I scale to users, as I kind of think about the next set of services? So these operational and scalability type factors have been most important. From the technical set of requirements, the key set of requirements are really around broadband, having broadband quality of service. And as I said, they're really application level metrics that ultimately are the ones that really matter. Though we can kind of translate these as a communities have been translated to some baselines in terms of the bandwidth and the latency. A lot of the streaming services are certainly more tolerant to kind of higher delays, delayed variability. Once you move into more interactive services, things become more critical. When it comes to sort of human-to-human services, these are still within tolerable realm of ranges. It's like once we move into automation, that things become a little bit trickier. Thinking about maybe next generation services that your residents or your businesses may care for, and that's when things become a little bit, the latency becomes kind of a much more critical factor. And then along the sort of requirements or constraints really came some of the deployment challenges in terms of terrain, environment, coverage. Ellen will talk a little bit more about we'll talk more about that, but in terms of just the physics of wireless transmission and some of the challenges there. So the specific technologies that we looked at were a combination, as I said, the ubiquity-based solutions, and then the second two were looking at a private cellular-based solution, and what the implications of that could be, and then at satellite with Starlink really being as the go-to example there. When it comes to private cellular, there actually are a number of different options, but the specific one we looked at is something that's completely, well, it's open source. You could contract a private cellular service through some of the traditional telecom providers, but they will just set it up for you and just operate it. So in terms of the ubiquity-based solution, I guess this was the one that really inspired us most. I mean, certainly we knew of these examples, but the level of the scale of operation, the kind of the robustness of operation that has been in play here was really impressive. Ellen's students, they've gone through some of the measurements, and they have some concrete data in the next presentation. So sort of skip through this. One of the things that was particularly kind of that we particularly noted was around the business model when it comes to this solution. And so it was interesting to observe that there wasn't a single one, first of all. And so there were kind of among the communities we spoke to, there were different decisions in terms of how from a business model perspective, what would be the end user charge for what would be required from end user to subscribe in terms of end user equipment. It ultimately wasn't clear to us that what was all the data that was informing this decision. It seemed like decisions that were made from maybe certain practical constraints at the kind of time of rolling out the service, and that it wasn't necessarily something that was kind of clear, what's the demand, where's the profit, like, sort of that part. But this is kind of just talking across multiple. I'm not saying that one was profitable, that none of them was profitable, or that one wasn't. It wasn't ultimately at the end of the day. It wasn't clear why one county chose to pick a different set of numbers, and whether there were any decisions that lessons learned from how the other county had set those numbers, or the other city had set those numbers, and they were making an informed decision that like their model somehow, their community somehow different, and therefore they need to adjust them. So maybe this is a longer term study that would really require us to see where those numbers are. The third-party internet provider, ultimately from a technology perspective, what's involved, is similar what would be involved in providing, these cellular or wireless solutions. It addresses one major implication of the community itself being the operator, running the business side of being a network provider and the operation cost. The published rates with respect to AirFi are as follows in terms of the monthly cost and the data plan. Like neither one of them meets the less than $50 target goal. To what extent at a community level one can negotiate and a different rate, that's a separate question. As a number, this number would include things like troubleshooting, things like would address scalability, would address any of the deployment operation costs, monitoring, and so forth. So I'm not 100% sure what was the sort of final decision in terms of actually subscribing, just using this as a service as opposed to trying to build out your own when it comes to one of the communities. The private cellular, as I said, there are a couple of different models how one could get to a private cellular solution. So from an end user perspective, this just means you just have a SIM card in your phone, right? So from what your end users would need to do, you would need to distribute to them SIM cards for that private cellular in a way that you would go to AT&T, and that solves that's kind of that's the sort of technology interface. So there's no need from end users to install additional devices or anything like that. From the service provider's perspective, and this could be sort of community core, or in terms of ensuring coverage, it could be community plus some community level crowdsourcing, so as to you can spread out antennas. So this involves setting up antennas. From a cost perspective, sort of the creme of the crop right now, in terms of what's out there in terms of like the technology, because it's like 5G compliant from the open source boxes, and it has really good support. Are these Freedom 5 boxes. It's a bit of a backlog to get one of those. They can run up to 5.5K, or they can be priced lower, but sort of the bigger ones are 5.5K. They have around 2-mile coverage, which is why I said so you need some ability to cover a bigger grid, and so whether all of that is just on a community provided infrastructure or in some partnerships with residents to get better coverage, that depends. In terms of so you would get these boxes and these SIM cards, and so that gives you the physical layer of being able to, from the phone, get to a message, get to a box, but you need to run all the software. And so here there are multiple options from there are 3 dominant trends here. One which is backed by the ETSI, which is like the International Telecommunication Organization. One which is backed by there's AT&T and a few other traditional telco providers, and Open Networking Foundation. And then the third one is this Magma work, which actually from features seems to be most mature. it came as kind of ultimately bringing together a number of open source projects that were coming from different places. Actually, Facebook put a lot of investment into building it out, but they completely pushed it out because sort of from a kind of business perspective, corporate perspective, it's completely a separate foundation. It just, like Facebook invested, there were enough motivated researchers that invested into making this happen. I should say that, so what this means is, you can sort of download all the software, install all the software, it will give you dashboards, it will give you ability to kind of in real time monitor what's going on. There is also kind of a level that would allow you to use a third-party service to run the monitoring and operations of the network. So there's a fee of like a couple of $100s a month, that subscription fee, and this would be sort of the private seller provider would be the one paying this fee. So this is not an individual end user fee. This would be like the community would be paying this fee so that all of the operations and the management stack and interfaces would run and be managed for you somewhere it's not only that it would run in a cloud, it would be completely managed for you. So you will just have a kind of administrator interface to the dashboard, but any configuration of the network would be taken care of, which may make it very appealing. Right? From the satellite perspective, this is something that's still a bit out. But in terms of the promise, the options that are out there right now, if you look at kind of the base, not the coverage, and the base numbers in terms of bit rate, they, certainly from on the Starlink side, they're quite appealing. Steve mentioned some of the issues with latency. So let me see whether I have the latency numbers. So if you look at Starlink, there's around kind of 50 millisecond latency. Actually, the reported latency is under 20. From where these satellites are, in some ideal cases, they take 2 milliseconds, but that's it doesn't take 2 milliseconds. So in practice, their reported lowest latency is 18. There have been a number of tests that have shown it, like at different satellites at different points of time, 15. But I mean, it's not constant, right? These things move. They'll have like 100 kilometers coverage. So then you switch over to the next one. So it's not stable. The problem with with these, and really that's kind of the problem with any fixed size commodities. Kind of once there is more demand, you end up degrading the service. So the big issue here is that kind of these numbers of 100 plus megabit per second rate and these latencies are on basically unloaded satellites. And so once demand is generated, can basically fluctuate quite a bit. There is a launch plan, right? That there'll be more satellites, right? Cannot be infinite. There are again physics on how they need to be organized in orbit, but there's a launch plan that really makes a promise of having much better connectivity through this infrastructure tier, and it can address problems in areas where otherwise there other options don't exist or are too expensive. It can provide kind of an alternative for certain types of services. So there, it definitely is interesting. So one of our students, as part of this project, I'm joking. So he went over the winter break, went to national parks, and so all the restaurants during COVID, they had to switch to wireless menus. then all of them had to provide internet so that when you scan the QR code, you can download the menu. They all offer free satellite-based internet because that was the cheapest, most effective way for them to solve the internet problem. So from a longer term perspective, it really could be an appealing option an option that can address some of the connectivity issues or the connectivity issues in these less dense communities. Let me skip through some of this. From a more sort of near term, the combination like this, the cellular and the private wireless, the WIS-based and the cellular-based systems certainly are the ones that are more realistic. I feel that from the cellular technology, one aspect for a while was availability of equipment and some of the backlogs around this, and we still have these supply chain issues that will continue to be present, but there may be some deployment aspects that will make it easier in terms of reach and coverage to scale to a larger area with fewer devices compared to Wi-Fi based. And now the options are there for high-end cellular. So one of the really kind of two things that we were also looking to do, and one we're maybe like a little bit further ahead than the other. So we started putting together like an interactive web page, web interface that would, there are these technologies now that allow you to build interactive web pages that are kind of front end for big data sets, or for data sets and for spreadsheets, right? Front ends for spreadsheets. So one of the things that we're looking to build is like this type of service that would allow you to kind of like plug and play different parameters and to get more of a comparison sense. And I mean, to do it proper, this is really more of a like proper network planning question, right? To like answer the full breadth of questions around that may concern the decision is you need someone that's specialized in network planning. But there's still some number of parameters that kind of like a little bit more sophisticated than back of the envelope comparison you can do with this kind of tool. So this is one thing that we're hoping to ultimately get to a state that can be more useful to others. So the current working title is Persity. And then the other thing maybe goes a little bit more to the question that I asked Steve on like what other things would we need. I actually apologize if anybody's from Georgia. It was just like, too many years at Georgia Tech. It's like a knee-jerk reaction when you hear the word engineer, right? Obviously, there's a baseline that absolutely has been met. It has to be met. Residents need to have broadband, right? But one may wonder whether the current federal definition of broadband is the right definition of broadband when you start thinking about what are the kinds of things that we want to do with internet today, right? And so once you start thinking about next generation services, or maybe I don't even think that they're that next generation because they're already out there. Services that involve more automation, that involve like really, really large data, large image-based, like visual analytics. And there's a lot of information that we can get from analyzing image data, from soil pollution to crime to health and so forth. So once you start putting all of these things together, that will change bit rate requirements, the latency requirements, both kind of average and tail, like meaning the stability, right, the variability. And so, that's going to push us in different levels of bandwidth and latency guarantees. And that just build out, like scaling out existing technologies alone to get more satellite connections or more coverage with denser cellular or WIS-based deployments is just not going to, at some point it's going to be prohibitive, right? And so thinking about kind of how this ability to combine computation and just pure connectivity, where you can now start thinking, okay, what are really the services that I want to run in my network, and kind of the kinds of applications that I can support. I think those kinds of things become interesting. So I hope that there's some right point with all, or at least some of the communities, that we can re-engage on that particular conversation, continue the conversation along those lines, and find ways to re-engage on that. And so Vaibhav and Carol were the lead students. Vaibhav's visited here. Well, actually, they've both visited. Carol has a deadline tomorrow. Ketan's son has 104-degree fever, and his wife was at the hospital yesterday with the kid. He was on campus, and today they had to swap. The wife had to work, and he's with the kid. So, so that's why they were going to come together, but that's why they're missing. So, okay. So.
Does the federal government have the right bandwidth definition for broadband? Maybe just as a comment with respect to that, when do you think that bandwidth definition should be changed to? Because I keep getting asked a lot of questions with regards to clock speed, processing ability, and we're already pushing the limits of our computers in respect to the broadband speeds in some respects.
I don't think there is a kind of a single number question, because I feel that there are these different classes of services, and so then it becomes, so you have different type, demographics that may be, the gaming part. I don't care for that, and I still, I forget how old I am, and I still think 24 and 27, but I really don't need the gaming. All I played ever was my series. But there is, right, that demographic needs something very different, and I don't necessarily think that, that needs to be rolled into the same number, but somehow needs to be explicit so that you understand what are you providing. And so, gaming can be an optional thing, but if we start talking about telemedicine, maybe that changes. If we start talking about crime services, fighting crime, and police departments, becomes something else. If we start talking about smart cities, smart infrastructure, that becomes something different. So once we identify those sectors, and then that needs to be rolled into, okay, these are now the core services that this is what you need from that. Right?
Yeah, I hear the answer come back to, it's coming back to the consumer instead of the provider. The provider is the one that actually produces the bandwidth, and we're being constrained by what's going on in the provider world, not the consumer world. And how do we really help our community understand that it is the provider's responsibility to contemplate what their speed and availability is and move toward that, because of some of the things that you indicated in your earlier part of your presentation
have Yugoslavian connections, former Yugoslavian connections through my last name, which should be pronounced Zegera if it were being pronounced by the appropriate original pronunciation. My husband's grandfather came from former Yugoslavia to the United States in the I guess it must have been the 19-teens or so. Anyway, I knew Otto was from Macedonia, but I don't think about it all the time, but she reminded me as she was introducing herself. And I'm here with 3 students, Alex Elliott, Eric Greenlee, and Bea Palacios Abad, and they've all contributed in different ways to the work I'm going to talk about. Eric's brand new, so he sort of contributed. Oh, he was a chief photographer in a prior visit to Concord, and he's also been thinking about some things that I'll present at the end. So I'm very happy to be here. I'm actually going to take a little bit of a step back. So my group, we're networking people, and there's very nice synergy between the kind of work that Otto's group does and the kind of work that our group does, sort of letting us sort of span from all the way from the network up through services and into applications. So this is not going to come as a surprise to any of you who are in these communities, but I wanted to kind of use a data-driven approach to motivate the kind of work that we have done over the course of the project. So this illustrates the situation according to the 2022 Georgia Broadband Availability Map with respect to fixed broadband, 25 down, 3 up, in your counties. All right, so I snapshotted the portion of this map which is relevant to Concord, Woodbury, Spalding County. I had to put Concord on there. Woodbury came up on its own, but I did the best job I could to make it look like it showed up with that. So, so here the color coding, the light yellow is areas that are unserved, meaning that there is no provider who will bring fixed 25.3 to these regions, and you're seeing a tremendous amount of yellow in there. There's a few pockets of the orange being served. And those of you who are very familiar with these areas know exactly which cities those are. I see Zebulon in there, in Pike County. Spalding, a little bit different situation, some more coverage. And then the blue is areas that after the publication of this map have started to see some development. So the blue is the most recent changes happening within the situation of fixed broadband availability. There's another serious problem that exists with respect to the data about the situation. So the situation itself is quite concerning. Another thing that's concerning is that the data that the FCC, the federal government, has from providers tells an extremely inaccurate story of what the situation is on the ground. So here, it's a very nice website that allows you to take a slider across the map and see what the difference is between the Georgia broadband map and what the FCC map says. Again, fixed connectivity, 25 down, 3 up. And the left-hand side is what the FCC, based on providers giving them data, would paint as the picture of connectivity. And the right-hand side is what the Georgia broadband map illustrates. So, you can find your counties in there. The big takeaway here is extremely clear. There's a vast discrepancy between the FCC provider-based picture of broadband in Georgia and the on-the-ground mapping that the state has done. The third thing I wanted to do was to point out, those are availability. That was fixed availability. I wanted to talk about what people experience in terms of performance in the places where they can get connectivity. So I think Otto referenced Ookla. Ookla provides the best current speed test measurements for understanding network performance. And when you use Ookla's tools, that data goes to Ookla, and on a 3-month delay basis, and with an aggregation of grid blocks of 600 meters square, Ookla makes that data available publicly. So this data I'm showing you is from Ookla's public data source. And again, I've zoomed in on the region that we are most interested in. And this is the data points measuring fixed broadband. And they're in the grid blocks where there were 2 or more measurements. So I filtered out any grid block where there was only one data measurement. I took those out because the reliability of that data is suspect. So these are all locations where there are 2 or more measurements. And Ookla has a scale from slow to fast, which is a combination of upload and download speed measurements. So the yellow are slower, the red are faster. And the takeaways here, first, the data is very sparse, right? So there are very few measurements. Now, if there's no network, there's nothing to measure. So those 2 things are related to each other. But also we see an awful lot towards the yellow end of that spectrum, meaning slower data speeds, and when you take a combination of upload and download. This is for fixed. This is the picture for mobile. So broadband mobile measurements. And the takeaway here is almost nothing is known. Almost no data has been collected about the performance of mobile broadband. Actually everywhere. This is not unique to this particular area. Mobile measurements are just extremely sparse. So again, very few data points. You recognize data points on freeways, much more common than data points off of freeways. All right, so that's a sort of data backdrop. And so against that backdrop, some of the kinds of expertise and work that my group does sort of tries to address a bunch of these issues. So when we look at that, what do we see? That broadband is severely lacking, both fixed and mobile. The data about broadband is inaccurate, those FCC maps versus the Georgia maps. The performance data is extremely sparse. So one thing to know about is the service available or not. Quite another to know what performance you will see if you have that service. And finally, the mobile broadband, mobile performance data, there's almost none of it. Okay, so that's a summary from that data. My group works on network measurement, on analysis of network data, and we work on solutions that help to bridge or destroy the digital divide. So a couple of screenshots from different projects. This one on the lower left is an example of taking data sets from the FCC and from a large location services company called Skyhook, for whom we had a relationship that we could get their data. This is showing the difference between the coverage for, I forget which provider, this is one of the cellular providers. Differences about where the FCC thinks coverage exists and where Skyhook's considerable crowdsourced data says coverage exists. And one of the things that's interesting in this picture, and I could talk for a long time about it, but I won't, is that they disagree in both directions. So there's some locations, this is the state of New Mexico, by the way, blue and orange, this is where both data sets agree. So agree that there's coverage or agree there's not coverage. Then the purple and the dark blue are where one of these data sets says, yeah, there's coverage, and the other says, no, there's not. And these actually come in both directions, which is interesting, really a serious data challenge. And those areas are often on the border between covered and uncovered, right? This is the region where you're not sure. If you're in Albuquerque, there's coverage. You're in the mountains, there's not coverage. It's between those two that things are complicated. And just as an aside, we have a new project working with some folks who are statistics and machine learning experts to take data sets and do predictions of coverage. We know none of these data sets are perfect. They're incomplete, they have inaccuracies, but these folks have some math methods that we're going to use to do better job of prediction. So I don't want to spend too much time on this, but these are just to give you a sense of the kind of work that we do in our group. And so as the project was getting started last October, we made several trips in person down this way and also several virtual trips. We were hosted a couple times by Mayor Strickland and enjoyed our time in Concord. And these are the sorts of things we heard. Ada referred to this. Mobile, the municipal ISPs, were active and growing with a really impressive set of things that had happened on the ground. The customer base was modest, sort of on the edge of being sustainable, and a lot of desire to try to grow that customer base. We heard, particularly in Pike County, about portions of the county that were far from both current and planned deployments. So Pike has got some, especially to the northwest portion of that county, even these fiber plants that are to come in, they won't touch that. They're too far from that part of the county. And then also that some of the grant opportunities, which are trying to help communities be able to build out, were just, in many cases, not a match. You know, they needed a level of cost sharing that was 3 times the budget of the city. So it's a non-starter. Those grant funding programs were a non-starter. So, you know, we heard these things, and we, you know, when we try to match up what we know and what we can do with what we heard were needs, we decided to focus in on this desire to build a customer base, and in particular on a desire to show people what kind of performance Ubiquiti has and what those municipal ISPs can offer, potentially as compared to alternatives that people were already locked into or were paying for. So I'm going to describe 2 different measurement capabilities. The first one I'll describe just briefly. The second one I'll spend some more time on. So when you want to measure networks, you can do it 2 ways: passive and active. Passive measurement means you don't put any new traffic on the network. You just watch what's happening. So you can take a computer and plug it into a network switch and configure the switch so that all of the network traffic that's going in and out through the switch also comes to that computer. It just makes a copy of it. So you don't interfere with what's happening. It's like a passive tap into that data stream. There are tools that have been initially developed in the researcher community, but now commercial, very commonly used tools. Zeek is the name of the one that we put in place, and Alex, give a shout out to Alex for doing this work. Zeek allows you to pull that data in, and then we can run it through an anonymizer, because we heard that you know, people don't really like you paying attention to what they're doing on the network. So we can run it through anonymizers that mean you can't trace back to any individual and what they were doing, but yet we can still retain patterns in the data. So it's important that we don't. You can anonymize to the point that you've lost any ability to do any useful data analysis because you've thrown away correlations that are important. And you can, so we back away from that level of anonymization, but still we cross that threshold that means you can't trace back to any individual. So this is a setup that some of our collaborators have used before to do monitoring in community-based networks in Southern California. This, as you can imagine, can generate quite a lot of data if you're pulling everything. You're pulling all the data off. We throw away the interesting part of the data. We keep just the headers, which is the only part we need for our analysis. But you still end up with an awful lot of data. And so we then, ship that data, store it locally, and then are able to upload it, send it off, and store it at Georgia Tech. And that can be done in the middle of the night when there's not much going on. So, this is the geeky portion about internet addresses and how we do anonymization. And I will, only if there's a question, when I come back to that. We have a running system that uses this Zeek to pull data out, runs the anonymization, is capable of storing data, and of shipping it back. We had that deployed in Spalding for 3 months, from April to July of 2022. At that time, I think the amount of traffic on the network was relatively limited. We were perhaps a little bit, playing a sort of parallel game of the network being deployed and the monitoring in place, and then more customers. And so, at that time, we captured what was there. It was the start of the dream for what will be carried eventually on that Spalding ring. And we are in conversations, have been in conversations with Pike County about moving that setup and doing some data collection in Pike. So that is pending. We are capable of running this in any community that would be interested in partnering with us. So if that, to you all or anyone who might watch this video, if someone was interested, here's the contact information. So I want to spend more time talking about the active measurements and the setup that we've created for active measurements. So passive measurement can observe what's happening on the network. In active measurement, you intentionally create traffic on the network. You intentionally try things out. That lets you understand network performance in a way that passive, you can understand some things about network performance from passive monitoring, but it's more often we use it to understand things like what's the mix of applications that people are using. Are they sending large amounts of data versus small amounts of data? Less end user performance oriented. With active measurements, we can exactly model, we can essentially pretend to be an end user, put traffic in the network, and we can measure and record that performance. And it also lets us do, if we put two technologies, say Ubiquity and a cellular provider right next to each other, we can do head-to-head performance comparisons. And so these head-to-head performance comparisons were really sort of the core of what, from a technical standpoint, we could provide that might then allow telling a story to potential customers. So the measurement setup, and I've got to say, John Strickland was a champ. I don't know what the whole set of words are for this, but, or maybe I should say his wife was a champ for hosting this equipment in his home over quite a period of time. So the measurement setup here, so we wanted to be able to do head-to-head comparisons. We didn't want to have to stick 4 laptops in John's living room. For one thing, that's an expensive way to run an experiment. It also takes up a lot of space. So Raspberry Pis are a computer on a small, very small form factor. And so Alex was able to get 4 of these Raspberry Pis so that we could run, and then we have 3 Android smartphones that are acting as hotspots for cellular providers. So we're going to run experiments from the Raspberry Pis. The phone is there to connect you from the Raspberry Pi into the different cellular networks. Plus we had 1 of those Raspberry Pis running with Ethernet into the Ubiquity connection in John's house. And then, okay, so that's essentially the physical measurement setup. Multiple 4N systems capable of comparing side by side. You need to surround that with the software that runs the experiments on a regular basis, records the data, and brings us back the data. And then on top of that, Alex was able to build a dashboard that shows you those results in real time and historical data. So just to tell you a little bit about what the measurement test suite was, we looked at Ookla speed test data. The measurement test suite, which is run on a periodic basis, I think once every 30 minutes, once every 15 minutes. So we were able to use Ookla's measurement code to test download speed, upload speed, and then latency and jitter. And speaking to gaming, latency and jitter are the key metrics of the network when it comes to much of the success of gaming. So actually Alex found a reference to some academic work to produce what's called a mean opinion score, meaning take these network measurements and give a score for if I were playing a game and this was the network performance, how would I feel that the game was good, whether it was a good experience or a poor experience. So this mean opinion score is on a 1 to 5 scale or something like that. It's always on a sort of relatively small, a scale like 1 to 5, where 5 would be an excellent experience and 1 would be a terrible experience. And this this is a function of latency and jitter, which is interesting because it's not upload or download speed. You know, games where you want to have a fast twitch, you're playing distributed with your friends. You know, you don't want some, I don't know, some treasure to show up and you're like can't get to the treasure, right? I mean, that's the anyway. So and then also we measured the time to load the home pages of a set of websites that are in the list of kind of most commonly visited websites. We put Georgia Tech in there as well, which is not on the list of most commonly visited websites, but not yet. That maybe this experiment will change that. So that's the test suite. The mayor's office, the mayor's house was our most common measurement location, but we also took measurements at outside of a business, a local business, happens to be a towing company. There's a guy in Concord who's got an awful lot of equipment in his basement. He's a ham radio operator. This is really, I put the photo even though it has nothing to do with our measurements because it's such a stunningly wonderful photo. There's a second tower on above shed. So we were able to measure at 4 different locations, but with the most continuous measurements being taken at the mayor's house. But there's a setup running currently at the second tower. So as we're speaking, data is being collected. And then, we ran some of these experiments from Atlanta, both to debug our setup, but also it's a useful comparison point. What do you see when you take these measurements from an urban area versus, come down this way and take them from here. This is the dashboard. It allows you can pick a location, you can pick provider, it will show you graphs, and I'll show you a couple of those in a minute. You can also you can download the data directly into spreadsheets to do additional comparisons. So a nice, fairly simple, hopefully fairly intuitive dashboard to let you get into that data and pull it out. Here's an example, and this is showing one of the. So this is not a head-to-head comparison. This is the ubiquity performance over a couple of days, 1, 2, 3, 4 days or so. The top, and so time is running on the x-axis. The top is latency measurements. The middle is upload speed measurements, and the bottom is download speed measurements. And just for your kind of reference points, the scale for upload, the 20 megabits per second is running about through the middle of that. And on the download side, 40 megabits per second is about at the same place where 20 is up above. So there's variability. That's interesting. It's on a time scale that probably means it's not real evident to you when you're using it. I think, John, you commented about that when you saw these. You were like, well, I don't feel that difference. If it changes relatively quickly, then the mean is really what affects what you feel, and the fact that there's upload and download bandwidth variations, as long as it doesn't last for too long at the lower rates, can be hidden from you by applications. The latency is relatively consistent with a couple of spikes. And the ratio upload to download, you're seeing about twice as fast, approximately, download speeds, 40 megabits per second or so, as compared to the 20 megabit per second upload speed. That's not surprising to see that kind of asymmetry. So that's an example of the kind of data that we've collected. This one is interesting. I think this was at the ham radio tower. So here we saw evidence of an outage that lasted for about 6 hours. So upload speeds went almost to 0. Download speeds were. So actually, outage is probably not quite the right term for this. This is a disruption significant enough to cause these measures to drop considerably, but not to go to zero. And I'm going to tell you, I don't know what was going on. It's possible there was a storm. Yeah, so we have not done the digging into what might have been the root cause, but, and you always have to ask yourself, was it a measurement? Is this a measurement artifact? I don't think so, but yeah, you know, when you see data like this, there's a lot of questions to ask, I think what's interesting here is, you know, you are seeing that there were some latency spikes. That upload speed went way low. The download speed remained kind of tolerable, but still quite a bit lower than it had been in its steady state. Yeah.
The upload speed there is right around 100 megabits per second, and the download speed looks like with past outage, it looks like it's about 65 or 70 on the mean.
Yeah, you know, I think the order of upload and download is swapped on this, which is weird, right?
It might be swapped in the titles.
The titles, you think the titles might be reversed? They probably are.
But whatever the title is, should be right.
Should be right? Yeah. Sorry, say it again.
The upload speed is 80.
It's strong.
Yeah,
it's strong.
really strong.
Yeah, actually these numbers, you should go live at the ham radio tower site because he's got better numbers than you do.
The speeds are absolutely
The speeds the speeds are fantastic. And then just one more result where we saw what looks like a relatively regular spike in latency. And I point this out because, you know, these things capture our interest. There's a lot of work to figure out the why behind any of these, and you know, we've put a lot of our effort into getting the tools up and running. The whys are sort of a bit of a downstream question. So this is, and then one final result here, which is looks different because it was collected over a much shorter period of time. So you know, you kind of want to concentrate on the points here, which are a little bit hard to see. But this is a comparison between T-Mobile, Ubiquiti, Verizon, and AT&T. And you know, so on the latency, lower is better, and Ubiquiti is the one that's way down at the low end. Of course, on upload and download, higher is better. And in both cases, the Ubiquiti network is kicking the butt of the cellular providers. So. So status of this, we are currently measuring, as I said, at the ham tower. I could do a live demo. That's always a little exciting. Alex is...
I just want to know where the button is that we can push that can turn the lights on and off at the mayor's house.
Yeah, that's coming. We're gonna sell access to that. You can do that with the Raspberry Pi. That's right. So again, this setup is available for additional measurements, and you know, contacting Alex or contacting me, we could chat through that. I wanted to say, I'm going to highlight two things that we are currently doing that are adjacent but potentially interesting. One's brand new, and we're not sure yet where it's going to go, but this is something that Eric, who's just started at Georgia Tech this fall, is looking into, and a motivation of it is. John, you recognize this picture.
We cut that tree down.
Yes. The branches that you see on the ground are a very recent modification to the network, which is to remove foliage that was blocking line of sight. And Alex and Eric happened to be in Concord when modification was being made, and Eric cut it on.
Very successful.
Yeah, that's great to hear. So you see the equipment right there mounted on that pole, and you know, we know that line of sight obstructions affect network performance. My favorite kind of story to tell from this interaction is about the Walking Dead truck that blocked line of sight for a period of time.
In this case, we're working on that ditch that's where that pile of rocks is right there.
Yeah.
In the county, we had a truck parked there. Well, it shoots right down to that right in line with that, so that whole subdivision got cut off that day.
Yeah.
I could have cut the water off and had less complaints.
We can always get a bottle of water, but we can't get a bottle of internet. So we know line of sight obstructions affect performance. Network planning, so if network planning tools could be more aware of built environment and natural environment obstacles, that might assist with more robust network design. And so we've been chatting with some experts in the computer vision area about taking foliage data sets and thinking about how those might work in with existing network planning tools to do, to provide some network design advice or check against certain designs to see what we might predict about performance based on interactions with line of sight. We've talked about the vehicle problem. That's a much harder one to solve given the relatively transient nature of the Walking Dead and other work crews. The other thing I wanted to mention is that, and Bea is really taking a lot of the lead on this, we are developing an FCC compliant mobile app to measure cellular mobile broadband performance. So, as you all are probably very well aware, a lot of money is about to come from the federal government to the states, and hopefully from the states to communities like yours for extending broadband. And being able to document the state of coverage and challenge providers who say we are providing this coverage to be able to come back with on-the-ground measurements that are that meet the FCC's requirements for challenges. This is going to become incredibly important. Already is important. Incredibly important for being able to get access to funds. So we have a prototype mobile measurement app. We're making the changes necessary so it meets FCC compliance, which is a whole nother set of complexities. And then working on tools that would allow communities to coordinate their own data collection, to own their data while also sharing it as they would like in order to mount these challenges, and be able to build maps that could be used locally for various purposes, but also could be used to mount challenges. So this is a project that, fingers crossed, is about to sign the contract with the Rockefeller Foundation. They are very interested in putting tools into the hands of communities that will allow providers to be held accountable for providing coverage, and make sure that as these federal funds begin to be dispersed, that happens in a way that is more likely to have overall positive impact, rather than ways that sometimes these happen where the money goes not necessarily based on where the need is, but rather where the politics are. I'm sure there's going to, this won't be politics free, but these challenge processes are really intended to add data to those conversations and data to that decision making.
And I don't mean to interrupt you.
No, go ahead. I'm almost there.
One of the things, you've got my brain just working wide open right this second. One of the things that our water authority does on a biannual basis is they do an overfly for our community to do a couple of things. One, for stormwater, they look at impervious versus pervious areas, and they do that through the flyover with ground penetrating radar or with infrared camera systems. What is the possibility of us coordinating those types of opportunities to fill in the gaps for that data set that you're building?
Yeah.
Because you're looking at foliage when you're doing it.
Yeah, that would be amazing. What we're finding is, there is satellite imagery.
Yeah, but that's not close enough.
But that's not what we need. And in fact, because a lot of these, as you know, you have the high towers, but then you have more close to ground level. We actually need to know what the ground cover situation. We need to know below. Where does the tree? What's the pruning, right? And 6 feet up, 10 feet up, what do we see if we try to? So that would be extremely interesting.
Yeah, because if they're running 5,000 feet for their overflights and they're doing a grid for the entire county so that they can see, because one of the things that we locate from that is where water is actually perking from broken pipes from the water system. Well, if it's capable of seeing that, then it's capable of really highlighting the foliage areas that we can come back with that data set and say, all right, here's areas of opportunity.
Yeah.
I just see that as an excellent opportunity.
That does sound extremely interesting. Yeah, let's definitely follow up. When's their next schedule?
Actually, it's being planned right now.
Okay. Yeah, wonderful. Okay, so you've met the students earlier this morning, and really want to give them a shout out for the hard work that they've done, and everyone has contributed. Alex has been kind of the prime developer of all the measurement systems, and made the most trips down this way of any of us. And finally, I want to thank the community partners for your time, your dedication. John, we really appreciate all the interactions we've had with you. The local IT experts who are so critical to this work. And then, of course, the Georgia Smart Program for the Vision and Partnership for Inclusive Innovation for putting it all together. All right, that's what I've got.
Thank you. Thank you so much again to all of the communities who worked with us in West Central Georgia this year to advance connectivity across the state. We are so looking forward to how this continues to develop. Of course, we owe you all a lot of gratitude for hosting us here, especially in some cases in their homes. So thank you so much for that. With that, we will conclude the kind of presentation portion of this event. Before we move to the bus tour portion of the event, I hope that everyone, don't be shy, please come join me for a photo that we'll take just before we move onto the bus.